We've got some division problems here, and in these, notice that we have a single term denominator, one term in the denominator for each one of these. So we can use, in the first one, the quotient rule for division. So I'm going to do this right here. Let's do it here. Here's number 1. We've got 15m to the 6th over 3m squared. Now the 3 will go into the 15 5 times. M to the, now you remember the quotient rule goes like this. You're dividing. So what do you do with the exponents? You subtract them. So it's going to be 6 minus 2. We'll get 5m to the 4th. In problem number 2 now, we've got 12a to the 4th plus 9a cubed minus 15a squared, and we're going to divide this whole thing by 3a. Now, we're going to use the property of fractions that says we can do this. As long as we have a single term denominator, we can write this fraction as 3 individual single fractions like this. 12a to the 4th over 3a plus 9a cubed over 3a minus 15a squared over 3a. Are you convinced that that's going to work? What if you were given these 3 terms right here? Here's 3 fractions. They all have the same denominator. So you would just write that denominator and operate on the numerators, giving us this. We're just going backwards now. So let's make these divisions. 3 into 12 will go 4, so we'll get 4. And then what about the a's? Well, using the quotient rule, we'll take the top exponent minus the bottom, or you can think of it like this. This is a multiplication, right? A repeated multiplication. I've got 4 a's up here. 1, 2, 3, 4. Right? 1, 2, 3, 4. And I've got 1a down here. Now that 1a will cancel with one of those 4, leaving 3. So 4a cubed plus the next one. 9 divided by 3 is 3. You've got 3 a's on top, 1 on the bottom. That 1 on the bottom will cancel with one of those 3 on top, leaving 2. Right? Or by the quotient rule, 3 minus 1 is 2. And the last term will have minus 15 divided by 3 is 5. A squared divided by a is just a. Right? 2 minus 1 is just 1. There we go. We've got number 1 done, number 2 done, number 3. We have 32y squared minus 40y minus 7. We're going to divide that by 8y. So let's break this up. 32y squared over 8y minus 40y over 8y minus 7 over 8y. Now, in the first term, 32 divided by 8 is 4, so we'll get a 4. And then y squared divided by y? Subtract exponents. 2 minus 1 is 1, so we'll get 4y minus. And then what do we get over here? 40 divided by 8 is 5. And then you see what happens here? These y's are going to divide out, right? So you get y to the 0, or just 1. And then, now we can't make this division here. This is our remainder, so we're just going to that's what we're left with. Negative minus 7 over 8y. That's the best we can do with that. Or we're going to break this one up into, 4 individuals. So we're going to get 12y to the 9th over 4y to the 10 minus 10y to the 8 over 4y to the 10 minus 40y to the 7 over 4y to the 10, and then plus 8y squared over 4y to the 10. Now we can do some divisions here. 12 divided by 4 is 3. But then what have we got here? There's 9 y's on the top and 10 on the bottom. 9 of these 9 will cancel with 9 out of the 10, leaving 1 on the bottom. Or if you like, 9 minus 10 is y to the negative 1, but y to the negative 1 is 1 over y. Now the next term, 10 divided by 4. Not much we can do there. We can reduce it, divide each one by 2, so we'll get 5 over 2, but then what about the y's? I got 8 on the top, 10 on the bottom. These 8 will cancel with 8 out of those 10, leaving 2, so that'll give us a y squared. Minus, now 40 divided by 4 is a 10. And what about y's? There's 7 on the top, 10 on the bottom. So these 7 will cancel with 7 out of those 10, leaving 3. So y cubed. And now I just realized that this last term here is not squared, but rather what? 2 to the 6th. Let's fix that if I can. Oh boy. Okay, so we're going to get 8y to the 6th, to the 6th, y to the 10th. Okay, so we can still do this. What are we going to get here? 8 divided by 4, 2. Now what about y's? Kind of a mess up here. We got 6 on the top, 10 on the bottom. These 6 will cancel with 6 out of those, leaving 4. There we go.